Hello everyone. So in this lab, you will be varying the volume of a sample of gas and measuring the change in pressure. So what you're studying is Boyle's Law. So Boyle's Law has to do with pressure and volume, right? And if you have really gone into depth and you understand, the major differences between all the simple gas laws, you know that Boyle's Law is an indirect relationship or inverse, which means that if one goes up, then the other goes down. So that's what you're witnessing here. You are going to change the volumes and then measure the pressures. And based off of this information, you can make an educated guess that the pressure will go down. But you will actually do this experiment using the online lab sim. And then, so you're going to record some data from that, and then you are going to graph that data using Microsoft Excel or something similar. So, as always, you are going to open up your Hayden McNeil site. I have Lab 10 already available, and you're going to open it up using the green notebook icon, and then you're going to read the introduction, always important, and head over to the procedure on page 2 once you are done with the introduction. And then you're going to collect your data. So for this lab, you will be completing all of the experiments. So there's 2 experiments. All it really is you're doing one gas on one experiment, on one trial, however you want to think of it. And then you're repeating the entire experiment, but with a different gas. So that's the only difference. It's the same procedure, you're just repeating it with a different gas on the second time. So that's why I have here, please use the correct gas. One of them is very different from the other, right? So 2 different gases, make sure to use the right one. We're also making an assumption, and the introduction mentions this, and I'll point that out to you. But we're making an assumption, can I talk today? That the temperature remains constant. And because the flask is sealed, that the number of moles of gas remains constant. So we are under the assumption that no gas is escaping, there's no moles leaving, and in that way, that isn't being taken into account, affecting the pressure or the volume, and we don't have to worry about that. So that's one thing about Boyle's Law. You have to hold moles, and the other property, which is temperature, of course. So the 4 properties of gases are PV, N, and T. Whenever you're studying Boyle's Law, you're studying P and V, which means that you have to hold these 2 constant. Okay, so we're assuming both of those things, and that lets us study P and V. Another thing to note, when you add 20 ml of water, then the gas volume is essentially minus 20. So 314 minus 20, that gives you 294 for the gas volume. So the water is taking up some of that original volume, and then the next time you add another 20 ml of water, it'll be 40 that you're subtracting, and you end up getting 274. So just keep that in mind, that every time you add water, you are taking out, you are reducing the amount of volume that is available for the gas to take up. When you graph your data, put the pressure on the y-axis and label the pressure in ATM. Make sure to always label your units. Put the volume of gas on your x-axis, so gas x-axis, and then the pressure on the y. And then remember to put a title on your graph. It usually goes something like this: pressure versus volume. You typically put the y first and then the x. So you're going to graph your results. Now I have this in detail here, laid out step by step. It's all on step 8 here. Now, these steps are specifically for Microsoft Excel desktop. So when I made these steps, or when I wrote them down, I was using Microsoft Excel desktop. I really can't talk today. But anyway, if you don't happen to use the same exact version, such as Microsoft Excel Online through like Office 365, or if you use Google Sheets, and both of those are perfectly fine, just be aware some steps may deviate. So it's easiest if you are able to use Microsoft Excel. If you find that you're having some issues using, the online version of Microsoft Excel, or if you're using Google Sheets, just let me know. I'll look for a video that can help you out if you don't happen to be able to find one yourself. But feel free, if you're using one of those other versions, to go on YouTube and just search how to graph on Google Sheets, for example, how to create a scatter plot on Google Sheets, how to create a scatter plot and graph on Microsoft Excel, Office 365. So feel free, but just in case you happen to not find one, let me know and I'll find one for you. So I will walk you through these steps at the very end. It looks like a lot, but honestly, it's not too bad. Thank God. And it's quicker than it looks. And then at the end, you're just adjusting the title, x-axis, and y-axis. And then you will complete the lab, as always, and upload to the assignment link. That's nothing new. So I just wanted to show you what the data collection portion looks like. It's honestly not much. You honestly don't even have calculations to do, so it's an easy one in that sense. But I do like this lab, and that you are getting the opportunity to learn how to make a graph. I think that's a very useful skill. So you're going to do experiment 1 for propane. That's what's going on here on this first table. And then you're going to do experiment 2 here for butane. So remember I said it's the same exact experiment, it's just with a different gas. That's why you need to make sure to use the correct gas. So you will be recording the volume of water within your flask, the volume of gas. Remember that has to be calculated by subtracting off the water. And then you're recording this. So these pressures right here are what you're actually recording, because that's what you're measuring. So just a reminder, you're preparing those 2 graphs, one for propane, one for butane. So you can either insert them here, right click if you have it copied, right click and insert it, paste it. Or if you want to create another page, please add it there. So let me show you. You could just press enter and then insert both of them here on a new page. Please upload all as one PDF. That's all I really ask for. You can put them here before these follow-up questions, or you can put them after. That's not really the issue. The issue is all one PDF, all one file. It can be all one Word doc or all one PDF. PDF is usually best, just as long as it's one file and you're not uploading as like 10 different files. That's when it gets really just time consuming for me on my grading end. Okay, and then some follow-up questions. So what relationship do you observe? And we kind of talked about that at the beginning, so hint, hint. And did you notice a relationship between your data for propane and your data for butane? So I really like this one. I'm not looking for a yes or no answer. I'm looking for an open-ended, answer. So I'm going to add here just a reminder, please answer in a complete sentence. And I'll probably add here that this is experiment 1 and this is experiment 2. Now, let's go ahead and head over to Hayden McNeil. So I went ahead and opened up Lab 10. It's the same way as always, where you click the little green notebook Let's head over to the introduction page. I was already on the second page, but here's the intro page. It discusses who Boyle is. His name is actually Robert Boyle, 17th century, a long time ago scientist. And this is Boyle's Law. So Boyle's Law has to do with pressure and volume, like we said. It's directly related to a second state of the pressure and volume. So essentially, this has to stay equal, these two sides. So if anything changes over here, like let's say you decrease the pressure from 1 to 2, then that means this has to go up to make up for it. So you can think of this like a seesaw. If one thing goes up, the other one has to go down in order to hold everything equal to each other. That's what I was getting at. And remember I mentioned how in our lab, we are assuming that the temperature stays constant, and this is why. So in a classroom lab, if we reduce the volume, this would have effect on the temperature, and we're not trying to look at the temperature, right? So if we were in a classroom laboratory, we would have to wait for the temperature to return to its original value. But in this lab, we can assume that the temperature remains constant, and that's why we can take those pressure readings immediately. So that's the good thing about the virtual world, right? So you definitely read through that, keep in mind what equation we're working on. And then here is the procedure. So experiment 1, you're looking at, of course, the volume and pressure of propane. And then for number 2, remember I said you're just repeat these steps of experiment 1, but you're using butane instead of propane. So I went ahead and entered the lab. I'm sure you've had enough of like entering the lab and the animation and everything, so I think you're good. So some new things that you're doing in this lab, you'll notice, or some new things just regarding this lab overall, you'll notice that instead of little containers, you have actual gas tanks up here. Of course, you have different gases that you can use, so just make sure again to use the right one at the right step that you're taking. So if you're on experiment 1, you would be taking propane first and then butane after. So other than that, you also have a pressure gauge, which you've probably never used. So it is easy to use. You can toggle between the different units, lots of different pressure units. Make sure that you end up on ATM, because you'll notice that we have bar, mmHg, a bunch of different ones, torr, pascals. You want atmospheres. That's what you're going to be measuring in. Okay, so you just click on the blue button and it changes it for you. Now, another thing that's important that you may not have done yet is closing your flask. So we need to seal this. So we need to close it up. So you double click it as always when you want to turn things off and on or change the view. And you click closed and then done. And notice that it has a stopper on it now. Now the good thing is you can attach the pressure gauge. We want ATM. So here we have the pressure gauge attached to the sealed, closed Erlenmeyer flask, which is what we want. Remember, we don't want moles to escape, so we're assuming that every time we add more volume of water, the moles are staying the same. So beyond that, another new thing that you would be doing is adding a gas. So you've never added a gas, so it doesn't let you bring it to the bench directly. At least it didn't just now. Don't know what's going on. But yeah, something's wrong right now. So whenever you want to add the gas to the Erlenmeyer flask, what you do is you bring it over on top of the container, and it's going to let you add in atmospheres. So make sure to read the instructions and add the correct amount. From there, in the following steps later on, you will be taking a graduated cylinder and adding some water to this Erlenmeyer flask. Now, you won't be able to see it going through, but there's a little entryway in here, right? Because it's sealed, that the water will be going through. So don't worry, you won't be able to see it directly, but the water will be added to the Erlenmeyer flask. So just remember, the overall objective of the lab is to add, you're going to be adding water in order to decrease the volume of the gas. And when you decrease the volume of the gas, something is going to happen to the pressure. So that's what you're witnessing here. That's the relationship you're witnessing here. And I'll let you, discover and explore that. Now, the last thing I wanted to address was Excel. So this is the desktop, really hard to say, desktop version of Excel. And I'm going to show you a quick run through of how to graph. It's really easy. So you always want to make sure that you label your axes. And I'm actually going to pull up the instructions just to make sure you can follow along. So you first have to start by entering your data, right? So whatever you record down here, that's what's going to be relevant to you, okay? The volume of the gas and the pressure of the gas. So that's what we mean by data. Now, for the volume, that's going to be your x-axis. And then for your y-axis, that's going to be your pressure, which I have it here. Can't scroll over right now, but I have it here. Your y-axis is the pressure. So we are going to start by labeling our x-axis and our y-axis. So the x-axis in column A and row 1, so just the very first tippy top, I'm going to say this is my volume. I was going to write gas. This is my volume in ml. And then over here, and you can widen it just so it's not overlapping and confusing you, this is my pressure in ATM, right? I'm going to enter my volumes here. So we know that our volume is going to be decreasing. So I'm just making up numbers. 5, 4, 3, 2, 1, right? Your numbers are not pretty and small like that. They are a lot bigger and not as, just simple. But that's the idea. You're decreasing the pressure. So what's going to happen? Oh my God, I just completely butchered that. You're decreasing the volume, right? So what's going to happen to the pressure? That's what we want to see. So I am just going to put in some imaginary, let's say this actually happened. I'm just, oops. Completely put in the wrong things. Let's say, yeah, and then, okay. Let's say we recorded that, right? So we did all our data entry. We inputted all of our X and Y values. Now we need to make the graph. Oops. So how do we do that? Select the entire 2 columns. And then there's several ways to do this, but I think this is the easiest way. Select the both columns with all the data included. And then you can click Insert. Here on top, and this is kind of limited right now, find the charts section, which is right here. There's a bunch of different charts you can do. You can do bar charts, you can do whatever this happens to be, pie charts, so many different things. We want our scatter, and we want the simplest version of scatter. Okay, we want just the very first one. And there you have your graph, right? Pretty easy. So I just moved it over. Now the last thing to do is to adjust the title, x-axis, and y-axis. Now to do that, you can click this plus sign, because notice that we don't have any axis titles here. Just add that, click it, and then you can edit. right? So I'll let you have fun with that. But here, we would like our x-axis name, which is volume, and then our y-axis name, which is pressure, and also make sure to always include units. Here, remember, I gave you some tips about how you would title this. It's always the dependent variable versus the independent variable. Dependent variable is the one that changes based off what you're adjusting. The independent variable is the one that you're choosing, right? This is your outcome variable. This is what you are manually changing. So you change the volume, right? So it should be, pressure versus volume, as I have right there. And that's pretty much it, right? It's not too difficult. Like I said, the only issues you may run into, if you do at all, is that there might be some, you know, slightly different options or steps for Google Sheets or for online version of Excel. But after that, all you have to do is copy it. So, let's assume you fixed the titles, everything's nice and neat. You can copy it directly like this, and I'll just actually go ahead and show you. You can copy it like this, just right click on the graph and copy. And then I'm clicking paste, and I'm pasting as an image, as a picture. And look at that, it's my beautiful little graph. Another thing you can do is you can print screen, which is what I included here. Control Alt print screen on your keyboard, and you make sure you have this open all big, and then you can insert it here to the lab, and you would be able to crop it and make it a little bit smaller. Another thing you can do is there is snip and sketch, and this tool allows you to click to select an area to screenshot, right? This is another way if you're working with Windows 10 and above. So there's several different ways to screenshot, but if you do happen to need help with that, you can always ask me. But I think everybody's pretty good with screenshots at this point. But of course, if you need help, just let me know. That's about it for this lab. Don't forget to answer these discussion questions, in a few sentences each, and include both of your graphs, either at the end or right here, and make sure that you have collected all your data, and then upload all as one document. And that's what I'm looking for. So thank you for watching, and let me know if you have any questions.